Hello YouTube! This is Big E-Money, $1,000,000 bills, and this is a Minecraft video about Minecraft clocks. And basically I'm going to show you 4 generations of clock that I've made and all the improvements between them. So if that doesn't sound interesting to you, then you should probably just, go watch another video on YouTube. But if that does, you should stick around. Alright, let's begin. What was that blue stuff? Weird. Okay. The first clock thingamajig I made was this. And basically it's a 100 counter, so you've got 10 lights at the bottom, 10 lights at the top, and it's made of 2 of these piston counters. Now how these operate is each time the pulse goes through it... Wait a minute, how the crap does this work again? Basically, every time the pulse goes through, it lets one more of these gravel blocks get pushed up by a piston, and the circuit sort of progresses through and covers one more line. And if you want to figure out how to do that, you should probably look up piston counters on YouTube, because I don't really have time to explain how all of these counters work and how to build them. Yeah, basically at the front of it you got a pulse generator, so that turns a positive signal into a negative for just a moment, and that triggers the whole damn thing. And here in the light display you can see it counting along. Now when this counter gets to the end, it's going to trigger this other signal that's going to run off all the way back here and power another pulse generator for this second piston counter that's going at the top. And this line at the back here is basically a reset line, so when you hit the final light, this goes back here and ends up resetting it, and that happens with both because they both tick over at the same time. We're going to see here this one's going to be 9 and this one's going to be 9, and they're both going to reset themselves at the same time. But yeah, and basically I had that idea, and then I wanted to make a big fucking groovy clock. So what I did was I hooked up this LED screen. It's 7 lights, hooked up to a shitload of wiring, hooked up to a counter, the same counter we have over here. So let's start that and actually see that going, because you're probably bored of me talking. Whoop. Oh, wait a minute. That may have screwed our thingamajig up. There we go. Make the signal a bit shorter on the repeater. And now we can see our clock is ticking from 9 to 0. And some things you should notice about this clock: it's the first clock I ever built, and the lag on it is shit. The numbers don't happen 1 second apart, and when each number flashes, sometimes these lights go off at different times, and the reason for that is every wire is hooked in with all this vanilla Minecraft circuitry, which basically involves shitloads of repeaters, so there's a different timing on everything, and it's pretty impossible to get it perfect. But yeah, and then I thought this clock, and the only problem with this clock, besides the shitty lag, for actual numbers showing in between numbers, was like after number 6, you have this repeater here. Piston counters don't really time well past 6, because you need this repeater to carry the signal through for you. So basically every number after 6 happens a bit slower, which is fucking annoying. Anyway, and then I thought I need to make the counter better, so I went back on YouTube and I looked up another counter design, and I found this thing. This is a NAND counter, similar to this one because it's 10 stage, but there's no lag after the 6th number, so it's superior, I believe. So let's start that up. Whoop. Now you can see that repeater Just going around in a circle, powering it. Okay, this basically goes left to right, and you're going to notice that they're lighting up in a chain, so the highest number, every one behind it is also lit up all the time, and that's a problem because when I have a clock I want only one of these 10 signals to go through at a time. So that's why I have the two next pieces of the circuit, which is basically an AND gate and an oscillator array. The AND gate, what that does is you'll notice when you'll notice down here that every time another one gets added on, the ones ahead of it, they flash for just a moment. So what this AND gate does is when there's a flash, it doesn't follow through, but when it's consistent, it does. So on this side, we don't see that flashing, that same flashing ahead of it. We just see the digit come on. Now I move to the oscillators. What these do is they subtract redstone signal. They can add it as well, but now they're subtracting. Basically how this math works is behind it, so 1, 2, 3, 4, subtracted by, oh no wait, that's not how it works. Okay. That's the source signal, right? So that's 15, that's the strongest, and then it counts down from 15, and when it's 0, there's no more redstone signal. So 15, 14, 13, 12, take away 15, 14, 13, 12, 11. 12 take away 11 is just 1. So when you see the one next to it goes off, it reduces the signal from 15, which lights that one up, to just 1, because it's 12 take 11. And then it just sort of goes up in that fashion. So every time one to the left goes off, it blocks all the other ones, and you only end up with one signal going through at a time. So I hope that kind of made sense. And basically that was the background for this clock. This was my second one. And if you're wondering what this big thing is, that's the final clock, the ultimate clock, but we're not going to get to that now. This one was originally powered by a NAND counter, just like the one behind us. Same sort of really rough redstone trail powering those lights. But what we're going to do now, I did have it rigged up to that counter, and that's just like the one we saw over there, but now I've actually hooked it up to a random number generator, just because that's a bit more interesting. So I'll show you how this works. What we're going to do is we're going to crack it open. Going to put a worm down there. Okay, now that worm, he's swimming around, and there's basically 10 buttons for him to stand on. He's zipping around, and he's touching a random one every time. So this makes a random number generator where these 10 buttons are hooked up to the 10 channels that lead to numbers being indicated. So what we're going to see now when we look at it is we're going to see a random number come up at random times, and on and on and on. I don't know what number that is, I'm sorry. 2, 1. Yeah, you get it. It sort of works. Sometimes he touches the buttons too close together and it glitches out a bit because all that redstone is fucking laggy and it holds signal when it shouldn't. Anyway, let's fucking turn this thing off. Let's let the worm loose. I would run all the clocks at once, but I do not have an Intel machine. I have an AMD, because I'm a cheap cunt. Whoops. Okay. Here we go. Alright, now after that clock I said, the problem with these first two clocks is that they show a state, but they don't hold it. Well, actually, this counter behind there would, but the first one, it didn't hold the signal, and with a NAND gate, it can, even though that one's not hooked up to it. So what this one was basically 2 NAND counters hooked up to each other to make a 100 counter, and I basically added a bunch of cool controls to it. I'll show you how they work before I show you the back of it. This is +10. tick, tock. I'm sorry that my video is coming out all weird and blue. I don't know why that is. That's a bit wank. And this one goes +1. Or +2. Example, and now you can start just a regular counter. And we can see it's basically a circuit here just going around and around with that light there showing when the timing is happening. And that'll just count up to 100 and then reset and then start again. This stops the counter where it was. Or, well, there's a lot of lag to it, but yeah, it works. And reset. That puts shit back to 0. Sweet. So let me show you how this thing works. We'll put 11 on it. Now I'll go have a look at the back. This is a shitload of redstone. You're probably thinking, what the fuck, how do you expect me to understand that? But all this gold stuff is a part of the final clock. So ignore that. What we're looking at is the silver stuff here, and here, and here. I originally made this clock in vanilla Minecraft, but it was laggy as shit, and I had to reduce lag to this first digit that moves more often. And how I did that was I used a Tekkit add-ons. You see our 10-step counter for the first digit. And what I did was I put wireless transmitters. So these you can set a signal frequency, and that'll follow through to the receiver, and there's no lag on that. So that basically turns a shitload of lag that we're seeing here into 0 lag, because all of those receivers are hooked directly to the light that they're needed for. Now if this is like blowing your mind and you just want to run out and make a clock right now, I understand, and you should do that, but you should like this video before you leave. Anyway, what else? Yeah, I don't think this big one needs too much more explaining. Let's go to the final, ultimate, completely overpowered clock that I made in the end. This uses a lot of Tekkit. This uses Computercraft, which is one mod included in the Tekkit bundle, and basically it gives you this computer block that you can use just like it was a classic terminal operating system. So if I type programs, it gives me a list of all the programs that's available, and it actually has like primitive paint, and you can set up file directories and stuff. It's crazy. It's like a little actual operating system. Anyway, I'll program the count. That's what we want to run. Welcome to count your current number. Okay, that's a bug, but if we go reset, we can see it's now 0, 0, 0, and if we look on the screen, it's also 0, 0, 0. That's amazing. Alright, let's see what else we can do. Let's see what to count. Let's run that first. Whoop! Counting has begun, and it shows us in the terminal, and not only there, but on this big panel with this groovy fucking switch that turns it off when we need it. Okay, now how this basically works is you have 3 sides, three redstone outputs that you're adjusting the strength of, and they control the 3 lights. And now this is our first one. You can see it's moving across quickly. Because we're using Computercraft, this fixes the timing problem perfectly. We can make it so that 1 second happens exactly between this number change. So this is actually running almost perfectly, almost with real time. Obviously you lose a bit of speed because it's like emulated in a game, but anyway. And basically these are hooked up to 3 more of these oscillator arrays. You remember this, I showed you the oscillator array back when I was showing you the NAND counter, and it works in the same way, subtracting and only letting one signal through to the corresponding receiver, which powers a number on this one, and so the middle one does the middle and the top one does the longest. And the really cool thing about this is that, holy moly, that's not good. Our clock is broken. Whoop. There we go. Fixed. Alright. Anyway, what was I saying? I forget what I was saying. Yeah, the cool thing about this clock is that there are 0 seconds of lag between the computer outputting that. Well, the lag for that is the same on all if it would be anything. The lag between here and here, if the wireless receivers are instant, which I believe they are, that is 0 as well. And from that receiver to the actual number is also 0. So what we have is a lagless clock, completely lagless, and it actually runs at 1 second intervals because I've programmed it to. Anyway, other cool functions I made in this program were count 10. This runs the exact same module that count does, except the sleep lag is less. Oh, this is really pushing my PC. Alright. Crap. Yeah, when I'm not recording and shit, it runs smoother than that, but you get the basic idea. It runs fast. It runs wicked fast until you press this button again. Now, with these I basically programmed it so when it counts down it hits 0, and then you could program it so like you had an input out the top, or well, yeah, that's the only side you have left, the top, so that could trigger something else like fireworks or something, but I don't know, I'm too lazy to do that. 420. Yeah, so that counts down to 0 and that stops. When it's counting up, it actually ends up counting to 999 and then resetting itself, interestingly enough. It also has add functions, but now you're seeing the count is probably less impressive. 411 plus 134 is 545. Yeah. And of course it also does minus and reset and exit. Let me show you how it does some error handling. If we go minus and we go a number that's bigger than 545, so for example 670, min error result is negative 125, increasing to 0. So that shapes it up to 0, so it's just a sensible output. Woohoo! Let me show you how you actually make these programs. They're very, very similar to Java. If you've done a year or two of computer science, or you've done some programming in high school, you probably understand what the fuck some of this means. Basically, it's just declare your variables. You can declare them inside functions, or you can declare them as universal, and you basically run modules that call on each other. So if we go to the very bottom, it's the countdown function. Lots of else if statements in that one. Add number. Oh, that's a pain. It looks, well, it is kind of complicated, but yeah, it looks more complicated than it is. Minus number, reset. This is a really short function. It's just like 12 lines or something. It's just setting every input as fucking 0. Repeat. So basically what this program does is those are all functions that haven't been called on. This is the first line that it actually executes in the whole program, where it goes repeat this menu. Welcome to count. Current number is that. Please select a input option, and then you put in a command, and then basically it just calls the module that does that. So that makes your programming way easy to use, and that's exactly how real programming happens. So it would be a good way to learn if you did not have any previous program experience. And fucking around with all these numbers just seems kind of fun to you. That would be pretty groovy. Anyway, and yeah, that's about it. That is generation cut, of clock building by me. Voila. Wonder how long that's been. Fuck it, I can probably just add some more stuff. Let me show you some other stuff in my Minecraft server, because we've talked as much as I think I can talk about clocks. Or as much as I want to talk. Ooh! Also, the screen, very thin. It's basically a widescreen. My first widescreen, completely wireless. This is some of the other cool stuff I made. This was a... If you've watched a lot of Minecraft vids, you're probably going to be like, oh, I've seen all this stuff before. I basically watched it and I went around and I remade it myself. This is a 9-digit pin. You have to hit the numbers in the right order, otherwise the door will not open for you. Wait, that should open now. Let me try again. Yes! Gotta be a bit quick with it. Basically, that's just a bunch of AND gates and signal repeaters fucking... Okay, I'm gonna try to do a tricky one. I'm gonna try to fly through the door one. Oops. Ooh. Swag. And this is a really simple device, but I just thought it was really cool when I first made it, is my automatic waterfall. And whenever I want, I can just flood this little bit of land. Yeah. Fun. Anyway, I guess the last thing I'll show you is my Juden Generator. This is a chicken generator. Similar to that worm random number generator we saw before. Come on, chicken, move. Show them the output changing. Do it! No. And this is my Juden Generator. Basically, there's a Jude inside this cage, and he doesn't move around often because he's depressed. Oh, wait, there he goes. And he can change the output as well. Same way that worm shit happened. And then that's all just logical gates and nightmarish crap you don't want to look at. Ooh, wait, let's look at this thing. This thing's pretty cool. This is my infinite... square pusher. It pushes this around in a square forever and ever and ever. Let's see if I can make another one. Oh, yes. Hopefully this works. There we go. Now you can see it happening. A 6-phase infinite stone mover. Fun. And yeah, that's pretty much all the crap I have to show you guys. Thank you for tuning in, and yeah, have a good one.